Okay.
So it's okay. Hello everyone, welcome to our today's session. I guess we are 13 now, so okay, people still joining us, that's good. And I guess we can start with the agenda now. So as you can see, actually I put the dates today, tomorrow and Wednesday, but most likely this is the schedule for today and tomorrow. Let's see how it goes for us, because I also want to include some practical things, especially on Git, what we'll do today. But yeah, so this week is a long week for us. We'll have 4-day sessions in a row. So just to be honest, that's the first time for me. So it's when I have so much sessions in a row. So let's see how it goes for us, and I hope it won't be tough for you. I'll also try to not make it complicated. So we'll just simply keep our normal tempo, and hope it should be fine. Also, I will for this week I will also give you the first practical exercise as your home task. So this will be for this week, and I will let you know. Maybe I can let you know right now. So this will be Git practical assignment. So this one. This will be the practical assignment for this week. Yeah. So basically it should be completed, I would say, until next Monday. Yeah. It should not be complicated. We will go through all the main approaches used here, and so maybe let's maybe start with a presentation. And after the presentation about Git, I will also explain maybe some key points from this presentation, from this practical assignment. So, and once we complete it with Git, because again, Git, in my opinion, is a very important topic. It's not only yeah. Any questions? Okay, that's fine. Yeah, because Git is because many projects use Git also for individual projects. If you and maybe your colleague, if you are collaborating on some kind of solution, then most likely you will use Git in this case. So this is a very important topic in different kind of software developments. So we will, and yeah, it's very important that we go through it and everyone can work on it, at least on the basic level. It's not complicated. Just we go a little bit ahead. There's no from my opinion, there's nothing complicated there. So no much things to remember, no much things to understand, just some basic things we will need to go through. After that, we will take basically this will be the short summary of from the previous session mostly. We will not take the full presentation. I just shared with you because there are 60 slides, and so we don't have so much time. Maybe we better move on with more relevant topics for us. because this presentation is mostly about the frameworks we want to use right now. And we need to, and then after that we'll start with the basics in C#, and these will also be basics which can be applied to almost any programming language. So then we'll discuss all these things. Okay, let's see how it goes. And right now I want to start with the presentation about Git. So for you, last time I asked to install Git on your computer. For those who use macOS, you would probably you need to use Homebrew. That's the special thing that cannot really call it framework. This is the tool which is used on macOS, and it can be used for different kind of tools like Git, and there are lots of tools. Maybe if you work on macOS, and if you work on some kind of development, coding, maybe different frameworks, then most likely for macOS users you would need to use Homebrew tool. But likely you can find all the commands needed for Homebrew in Google, and then just basically paste these commands and run them from terminal. But yeah, that's for Mac. For Windows users, you can simply download Git, and then we can use it. So, but right now let's start. So the presentation is about Git. So we'll talk about version controls in general. Then we'll talk exactly about Git. Then we'll compare it to another version control system called S3N. We'll talk about it, and yeah, so then I will explain details more about Git. After that, we will shortly talk about some agile development basics, and also we'll take some discussions after that. So first of all, what is version control system? Okay, maybe let me zoom it a little bit. Yes. Yeah. So version control, that means we have some kind of development. So we have, and as you already noticed for your first .NET projects, everything is based on the files, right? So we create the class, we write the code there, so we have the file. We compile the code, we have the file. We create the project, we have the folder, and so on and so on. So we have some kind of files, some kind of we have some kind of files. Also, we have the folders with different reallocation, and so on and so on. And of course, if the project is large, then of course there will be so many different folders, different files, and that's the first point. Yeah, so you have this project, and in theory, not in theory, but you'll make changes on it, right? So you change the file, you make an extension on the code, so to introduce some kind of new functionality there. And in this point, first question, the first motivation for us is to control the changes done, because you may have some changes, you maybe in the future you need to revert back, right? So in case you create some kind of development, you deploy this development, and then you find out that this is not needed, or basically something went wrong. And in this case, you may also think about as I just said, to revert back the changes, to make some adjustments in the let's say previous version of the code. Yeah, so the keyboard here is version. So you may have the versions of the files you are working with. Yeah, and that's the first step. not the first step, but that's the first, or maybe more precise, that would be the second motivation. But the first motivation, I would say, from the priority point of view, would be that you also need to share your project with someone else. Because, as you may understand, and as I mentioned in the previous presentations, usually we work on large projects, I mean, we as the developers, and it is not likely that you will work alone on the project. Most likely you will have your have another colleague who also works on the same project, on the same system of the files, so you can name it. And then of course you should also think about how you make the changes, how you deploy the changes together, because it's not like you're sitting together and typing on the same computer. It's not possible, as the option would be, and maybe the most primitive option to how to work if you are working together with someone else, is to simply share the files. It can be Discord or just by email or chat, and you just simply then to have this file sending to each other, and at the end you may get some kind of result. Of course, this is possible, and so in first look you may consider to do something like this, but in real life, of course, this is not how we proceed. So to proceed precisely, to make it more comfortable for everyone, to track the changes done by one or another user, we need to have version control. And so here you can find some kind of version control system used. So this is Git, Subversion, Mercurial, and BSR. I never worked with these two. But yeah, so Git is the most popular, and we'll see it in the further slides. So for example, yeah, as I said, how to collaborate. We need to collaborate with each other, and in this case, what basically happens in theory. So maybe first thought you can imagine here, what is the best way you can imagine how you and your colleague you can collaborate, you can work on the same project. Of course, I mean, the first thought may be that you have some kind of common folder where everyone have the access to. So it means that you have some kind of the folder, and then everyone can change this folder, and at the end this is the folder with the final version of your project. And so this is basically how the version control systems work. And there is the common folder. We'll later on see where it is stored and what is the function of this folder. And yeah, so that's so basically version control systems are based on the common folder where to which everyone, not everyone, or maybe the group of the developers have the access to. And so that's the solution, version control system, where everybody on the team is able to work absolutely freely on any file at any time. That's true, but in practice, it's not like. In fact, yeah, it's not like if you have a large group of the developers. Of course, it's not like everyone of the developers have the right access to the folder, because otherwise, again, this would be a little bit messy if, like, let's say, hundreds of people, of the developers have the access to write the same folder from. If this is a large project, that this may trigger some kind of chaos, of course. And in practice, there are some limitations of the of the writing access, usually there are no limitations on the read, so it means that this is the folder everyone can take a look on, can see what's inside, and if you need also download this folder. But to make the changes, usually there are some restrictions, and we will talk about them a little bit later. So the next problem may be that, as I said, about the version of your project. You may need to make changes, need to save something, and of course, how can we track it? The key point here is how can we track all the changes, and if needed, then revert back. And as the option, this would be the version control system. Yeah, so it means that you have the project, and you can simply track. You simply have access to all the versions of your code, and also you can specify at what point, what time your changes should be, say, confirmed. Yeah, we'll see later such terms like staging and commit, file commit. Yeah. And so this can also be tracked. You can say that at this point I want to make the version of my changes, and later on I can go back to this version if needed. Yeah, so that's the point. You can restore previous versions, and also if needed you can compare the versions. Like if you have the version from yesterday and the version from today, you can make the comparison and see what are the changes done. Yeah, so using the version control system, you can also find out exactly what changes happen, and on practice where it can help. So for example, you work on so let's say you have build software. Let's say that this is, for example, the website as an option. Website, for example, for e-commerce, for the customers, you work with the customers, then so you work on the changes, or anyone else work on the changes, doesn't matter, from your team. Then at one point the changes are deployed. The changes are deployed to the real website, and you see that not you, but maybe the customers see that something went wrong. There are some issues, something does not work as expected. So what you can do, you can simply check what are the differences between the previous version and the version deployed. So you see the changes, at what place what is done, and then to check it, and maybe this using this approach you can determine the issue, why something is not working as expected. So version control can also help us in this case. Yeah. So this is what I said. You can understand what actually happened, and at the end, if needed, you can make a backup. Yeah. So you can make a backup, and the good point is here that you make a backup, but you also have basically how it works. For example, for Git, you make changes. Then the next step is that you make the backup. So it means that you revert back to the previous changes. But what happens? It actually creates a new version. So it means that you have let me paint it a little bit. So you have the initial version. So this is the version. You make the changes, so you get this version of the changes, but then you revert back, and it does not just simply go back to this one. It takes changes from this one. Basically, it takes this version and it replaces it with this one. So in theory, it means that you have a new version, but the version is the same as before, and if it is needed, then you can simply take a look at what happens here. You do not lose this version. Yeah? So this version stays here. you simply, as the final version, you have this one, but all the changes are tracked, so you can also take a look on this version if needed. So it's not like you revert back and lose everything. Everything will be on place, and you can take a look later on this. And now we go to the version control systems themselves, and the most popular types of version control systems are centralized version control system. This is what SVN uses, and then we have distributed version control system, which is actually Git. And yeah, so now we can see the structure, how the centralized version control system works like, and what we can see here. What's the concept? So you have working copy. So let's say that in this case we have 3 developers who work on one particular project. What's this project? It doesn't matter. It can be just simply code writing or just any kind of file sharing. It does not matter what you do here. The idea is here that you work with the files. So this is the key point. What kind of files we're working with, no one cares here. So you have the files, and so you have the working copy. The working copy, just to make it easier for you, is the version of the project. Again, simply just to make it simple, that's the folder. Yeah, the folder with the files. You work on your computer. So this is what we call the working copy. Then there is another colleague, your colleague who also work on his or her folder, and called working copy on the computer, so another computer. And so there's the third colleague who also works on his or her own folder, so the project. Yeah. Maybe I will call it local versions of the project. This will be local project, local project folder, another local project folder, and another local project folder. So 3 different computers with the local project folder. And then we have we call it server. Maybe I guess the server. It's maybe fine, but it's maybe more. It's maybe too generic word here. So, but yeah, we can call it server. It doesn't matter. The main idea is that actually, that's the server, and the repository is placed on server. Yeah, it's a little bit confused for me. But yeah, so we have the remote server where there is the common repository. Everyone is so it is shared with all the 3 developers here. Okay. So and from the, if you already taken a look on the practical assignment for Git, so this is GitHub. We'll talk about the servers we can use, but as an example, this would be GitHub, the remote repository. We call it remote repository, and so this is actually the folder placed on the server, and every one of these 3 developers works on this particular folder. So it means that everyone has his or her own local copies, local folders, local projects, but the main folder, the general folder, is the folder stored on server, remote repository, and then everyone makes the changes. So like this developer makes the changes, then it pushes the changes to the remote repository. Then this developer, he or she this developer takes the changes from this remote repository, then continues to working, and the same for this developer. So everyone from these developers can. We talk about this game, of course. Maybe there's an option that someone has no access to the changes there, but so we will not talk about this scheme. So let's imagine that everyone has the rights to make the changes in this remote repository and to fetch the changes, to pull the changes from this remote repository. Yeah, so this is the scheme. The developers have working copy, and then there's the remote repository which stores the main project shared with everyone. So at this point, do you have any questions on this scheme? So that is how it works for version control system. Yeah. So again, 3 different computers and 1 remote folder available for everyone. Yeah, we will talk about how can this folder be shared with these developers, because again, as you may understand, there may be some conflicts with the file sharing and some complicities, yeah. And we'll talk about how this is handled. But yeah, this is how the centralized version control looks like. We will work with more advanced. Hold on, let me. Oh, no, I just need to zoom out. Okay, yeah. So this is how it looks. So every operation is performed directly on the repository. So from the workstation, we go to the remote repository and on the opposite way. So quite straightforward here. Yeah, drawbacks, it's not locally available, so it means that you always need to be connected to the network to perform any action. Yes, so this is about this point. And yeah, the next drawback is that if everything is centralized, so in case of any central server getting crashed or something goes wrong, then the entire data of the project may be not only lost but also corrupted. Yeah. So that's the problem. Why we want to use centralized version control. And when we talk about Git, you'll see what's the main disadvantage of this approach used here. So again, just before we start talking about it, the main disadvantage here is that all the changes happens directly, and so you do not have anything in between your working copy and the remote repository, because again, what may happen that the data can be corrupted, or it's your data on your workstation, or it's the data on the remote repository. So something may go wrong there. And the solution for these issues is distributed version control system. So short, we can simply call it Git, because this is Git. And so what's the difference here? The difference here is, as I said, that you have something in between the remote repository and your working copy you work with. So what happens here? Here you have one more stage, as I just said, and this stage is your local Git repository. Yeah? So in this case, we have actually 2 Git repositories. So we have Git repository available for everyone, which is stored on server. This is what we call, again, remote repository. And we have local Git repository, which is also stored on your computer, but this is actually the place in between your working copy you work with and the actual remote repository. So what's the advantage here? Just to explain, it's simple. So you have, let's say you are working on the project, everything is fine. You work with the project, let's say you are a new one on the project, because as I just said, mostly we work on the projects which are not just simply starting from the beginning from scratch. So usually we join the projects which have some kind of code, and so mostly we just work, we extend the current existing code. And in this case, what's the procedure here? You come to the project, you are new on the project, you have this. So what happens? You have your computer, you have the environment you can work on, and what happens? You simply create. Usually we call it cloning. Yeah, so it means that you clone this repository. So it means that you create the copy of this remote repository, remote folder on your computer. So at this point, you have basically the same repository as this one, but yeah, this right with all the history, with all the version control changes, so everything is stored there. And this is a remote repository. Then you simply uh, get all these changes from here, and then all these changes are copied to your working copy. And basically what happens? So now you have this working copy, all the recent changes from the main project, so you can now start the work. Again, so you do any changes there, so it may take maybe 1 day, 2 days, and whatever you want. So once you are making the changes here, nothing is touched on the remote repository, and also nothing is touched there. Yeah. So once you done the changes, you confirm the files you want to in this case send. We can say send to the remote repository. So you confirm these files. So in this case, we say we commit these files, and these files then will be added to the local repository. And what happens here before the push operation happens here? This repository will take care of the information received from the remote repository. So this is the buffer check in between this copy and the actual remote repository. So at this point, this local Git repository, it will control if everything is fine, that your changes are not conflicting with the changes in the remote repository. And everything is fine, the changes will be pushed. If not, then this procedure will not be allowed. It will ask you to do the updates, to adjust the changes on your working copy, and only after that you can merge your changes and send them to the remote repository. Yes, so in fact, what is local repository? It is the same remote repository, but stored on your computer, and it controls all the push and actual pull operations from the remote control. Yeah, so the advantage is that all operations are that's very fast. The tool only needs to be accessed the local drive remote server. So it means that you can simply work on your project. You can commit your changes, then the changes will be stored here in the local repository, and for example, before some point you can keep them in your local repository and not push them to the remote repository if you don't have such need. Yeah, and then committing a change can be done locally, and this is what I said, and you can control it more precisely. And yeah, so since everyone has a full copy of the project repository, then they can share changes with one another if they want to get some feedback before affecting the changes in the main repository. So that's true, and also at this point the changes can be distributed one by one. We'll also see the approach of the branches. We'll talk about the branches a little bit later, but yeah, so this approach allows the developers to deploy the changes more accurate and more safe way than it is done in the centralized version control system. And also, yeah, as it said here, if server gets crashed, that everyone has the local copy, and in theory it's quite easy to get the server back. And so in general, what is Git? That's an open, as I just said. This is open source version control system tool, and that's distributed. And in fact, when we talk about distributed version control, then usually we would just say Git, and this is correct. Everyone understands it. It's designed to handle everything from small to very large projects. So it doesn't matter how large your project is. So if you have some kind of local small projects, you can use Git, and also for large projects, you can also use Git. Everyone uses it. And so it's created in 2005 to develop Linux core of Linux. And so basically, yeah, that's most related to Linux, not Windows, but of course you can work using Git on every operating system right now. Yeah, so it has all the necessary functionality like performance, security, and flexibility for all the developers, and yeah, it serves as an important distribution control for DevOps tool. Okay, so let's talk about some features. First, it's very scalable. So if the number of operation it's increasing, then Git can easily handle all these changes. So if you have lots of developers, then this should not be the problem for Git. That's first step. Then it is also reliable. So in fact, there should not be anything that makes it complicated. That there's a possibility that your data is crushed. So at any point you can also revert your data. So from this point, it's very reliable and safe. It's also secure. So yeah, it uses SHAI secure hash function to make to name and identify the objects inside the repository. So that's also related to security. Maybe it's not what we will talk about, but just know that that's secure, also economical. So that's the central server needs to be powerful enough to serve requests of the entire team. Yeah, so in fact, for Git, this should not be the issue to work with servers. So if you work with some kind of servers like open source servers like GitHub or Bitbucket, then in fact there should not be the issue to add as many developers as you want to these hubs. Yeah, it also supports, as it states, non-linear development. So it uses branching and merging. This is what we also we'll take a look on the branching and merging. So it means that just in simple words, branching means that you have so-called parallel development. So it means that not just simply that you have this just one direct repository and just everyone pushes the changes on the exact version of the file. So you may have like parallel versions of this repository. Of course, usually only one version is used as the main version, but you may have the development in parallel. So it means that this guy works on one version, so on one branch, then this guy works on another branch, then this guy works on another branch. So what this means that yeah, of course they all push these branches to the remote repository. So at this point, this remote repository will have, let's say, 3 branches, as you just said. So it means that 3 different versions of the same repository, in this case. And at the end, so once the development is completed for all these 3 developers, then what we usually do, we merge 3 branches, one branch from this developer, merge from this developer and from this one. So then it is merged in the main branch, and we have the solution. So as we have the main solution. So yeah, this is easy branching. We can work on the branching in a very easy way using it. We'll see how to do it. Yeah, it's also distributing development, so it gives each developer a local copy and also the entire development history. So nothing secret and very easy to distribute and use. Yeah, also there's compatibility with existing systems of protocol like SSH. So that's also for the security reasons. And so now let's take a look on this graph of this chart on the companies using Git. So as you can see, Git is the most popular version control system nowadays. And so at the beginning of this decade, last decade, SVN was the most popular one, but of course right now you can see that the popularity of Git has increased, and that's for sure number one version control system in the world right now. Yeah, so you can also take a look on the popularity. It's the most popular for sure. So yeah, the difference. So I already mentioned the differences, but again, as I said, the main difference it's all for subversion. The problem is that so there's the server and there's nothing in between what you do and the actual server. So it means that if something goes wrong, you have no buffer in between. Yeah, for Git, you do not have this problem. So everything is controlled using the local Git repository, and the changes are distributed more precisely. But yeah, of course, the disadvantage from Git perspective is that it makes it a little bit more complicated to proceed as these changes. Sometimes you may face some complexities with pulling or pushing the files. You need to have, yeah, so what's the main complexity from my experience and from the experience of my colleagues is that you should stick to the last version of the changes. So what does it mean? It means that you have the repository, like your repository, then your colleague has the repository. You should in your local, I mean your workspace repository, and your colleague has the same, and you both have the local Git repository. So every one of you should, if you want to push the changes on the same track, on the same branch, then every one of you should have the last version of the changes submitted, changes pushed. And it means that you all should be on the same time track, version track. So you cannot just simply come from nowhere, then create your own folder and say that hey, this is the last version of the project, no other versions are relevant anymore. So that's not possible. You should work with the last version promoted to the remote repository. So what does it mean? It means that all the changes you've done should be tracked, and they should be yeah, so they should be tracked, and they should be let's say recorded. It's recorded in the Git remote repository. Yeah. So it will yeah, so that's the key point. All the changes should be tracked. You cannot just simply come from nowhere and with your changes and say that hey, this is the relevant version. No. Yeah, this is not how it works. So yeah, and the main drawbacks for the beginners is that it's harder to learn. Yeah, because it has more constants. Yeah, this is what I said, and also more comments. We'll take a look on them a little bit later. Also, you could see them in the practical assignment file. Revisions don't have version numbers, yeah, so it's yeah, that's true. But so if you work on some kind of more advanced ID than Visual Studio Code, then in such IDs I will show you later on how it looks like. But so at this point, if you work from console, from Git Bash, then this may be the relevant point. But if you work with the advanced IDE, I will later on show you how it looks like. Then the revisions and the version control should not be the complexity here. Also, many Git commands are cryptic and their messages are very user unfriendly. Yeah, this is true, I agree. Sometimes you may not really understand what's going on. And yeah, so there's also GUI, but yeah, so as I said, you can if you work with advanced IDE, then you can use it, and there you have the whole you'll see the whole situation, how your version control looks like. But yeah, I will show you a little bit later. This let's move on. So Git is faster. Yeah, that's true, but maybe for us it's not really important for now. We won't have any complexities, any complicated solutions. That's why it should be fast anyway. So yeah, about maybe shortly also about the commands. The good point is that maybe one needs to know all the commands. There are a few main commands which is likely to know, and it's preferable for you to know, and then you can simply use these main commands I will later on show you. Yeah, which to choose. Yeah, there are some bridges between Git and SVN, but usually most of us is using Git. Yeah, so the operations. Yeah, let's quickly talk about the operations. First one, that's initialize. It means that you create the repository. Yeah, Git repository. The next one is add. It means that you stage the files. So what this means that you work on your local copy. Yeah, so you have different files you work on, you make the changes. Then using add command, you can specify which files you want to move on to your Git repository. And this is what command add does. And so changes are done. You say add this, and this, or how it usually happens, you just simply add all the files you changed. Then all these files will be then tracked, and once you execute the command commit, then the changes will be moved to the Git repository, to your local Git repository. So you have the commit and commit. This is the operation, and also we can say that this is the set of changes. So let's imagine the set of changes. There's, let's say, the change in file A, and the change in file B, and so on. So you have all this set of changes which are stored under the commit. And so we call it commit. Then you have push operation. It actually pushes the exact command, exact set of changes to the remote repository. And pull does the opposite one. It takes the changes from the remote repository and moves them to your local Git repository, and then later on also moves the changes to your workspace. And there are some advanced Git operations. It's branching, as I said. So I just explained what the branching is. And the merging means that you have several branches, then you merge them into one. And also with basing, so I rarely use it, but means that you actually rebase your changes and replace with the total, with absolutely different version, but of the changes, but we will not, most likely will not use it. Yeah, so, and here's the very nice image to understand the concept of Git, how it looks like. And so you have all these stages. You have your working directory. Then you have the staging area, so it means that all the changes you've done, not all the changes, but you can select what are the changes you want to move forward. Then use git add. They go to the staging area. So once you're done with all the changes, you execute git commit. Then changes, the set of changes is moved to the local repository, and then it moves on and on the opposite direction. But git pull, you cannot really pull the exact commits from the remote repository, you just simply can pull everything. And then it goes to the local repository, and then you can check out and get the latest changes to your working directory. So basically, just in short, the most simple usage of Git is that you have your remote repository, you work with another colleague, and what you basically do. So you have the relevant changes pushed to the remote repository. So you have this project, you have these folders. Yeah, how it usually works. So at some point you want to make some, let's say you want to make some changes on the project. The first operation to do, first, before you start doing any changes, you call the command git pull. It means that you get the relevant, so before you want to make any changes, you need to get relevant changes. Of course, otherwise, if you work on the not newest version of the changes, then of course it doesn't make sense. You may have some duplicities, you may have some files to be missed, and this is not good. Yeah. So first of all, before you start doing any changes, you execute git pull. So now you have all the relevant changes on your actually, in this case, this image is not really correct. Git pull actually overrides the changes in your working repository as well, if everything is fine, of course. Yeah, so then you pull the changes, you have the recent changes in your working repository, so you can make your own changes. So once you're done with your own changes, maybe sometimes just to be sure, you can also git pull, just to see if maybe something is not deployed during your development. And then you execute git add, of course, git commit, git push, and you move your changes to the remote repository. So this is the simple way of using Git. Just a few commands to know. I'll later on show them, and you can simply move on. Yeah. So and here we go to the commands. So first command is git remote add origin, and then the URL of the repository. So the trickiest point from my point of view here is that you need to remember the sequence, and this is the usual problem, to be honest, for me as well. I sometimes mix up the sequence here. But of course, everything should start with git command. Yeah, you can execute it from command line. So if you git installed, so let's say that you have the command line here. You select the right folder from here, then git command will work. So for example, let's go to documents. I guess there should not be git status here. So you can execute git command from here. It doesn't matter where is it. But yeah, you can also execute it from git bash. Actually, there is no difference if git is installed on your computer. Yeah. So okay, so that's the first command. Git from git. Yeah. So we pointed this is git. Remote, it means that we work on the remote. And add, so it means that we add remote. Origin, that's the name. So we usually call it origin. In theory, you can also use another name here, but we always use origin, and then the URL of the remote repository. So at this point, it means that you have your local Git repository. You add the URL, but before it, it's not mentioned here, but I prefer that you always start using git init. Yeah, that means that you initialize, you create your own local repository first. I will show you, but maybe we can do it with directory right now. Why not? Yeah, I will not will later on create the remote repository together, but first of all, we have practical folder here. I will, let's say that I'll create new folder. Let's say that will be git test. And again, I prefer using git bash. You can use whatever you want. I guess maybe git bash is the best option. So the first command would be git init. And now the git repository initialized. You can see that this may be hidden. So I guess you can go to view and tick hidden items. If it's not hidden, it will be empty. But yeah, usually git is hidden. And now we have this local git repository stored on our computer. Now we can proceed with some changes there. I will later on show you what can we do with this folder. And then we have git push, and that pushes the changes to the remote repository. Git pull pulls the changes from the remote repository. Git clone, it means that we have the remote repository somewhere on the server, and then we can use the command git clone, provide the URL, and we will get the copy of the relevant remote repository. You can check some git commands here. There are lots of git commands, but usually I use only a few of them. Yeah, on practice, yeah, of course, there may be something complicated things to be done. Then of course some advanced commands are used, but usually there are a few commands used. And yeah, so here we go to maybe more advanced thing, which is branching model. It looks maybe a little bit complicated, but this is how it usually happens. So let's say that you have okay, here we have master branch. Yeah, so this is the main branch with all the main changes. So then what happens? At first point, you have the initial repository, the initial changes, then different developers usually create different, there's actually these branches, feature branches, so maybe this scheme is a little bit complicated, but what I want to say is that here we have the main track, so that's the master branch, and in parallel of this branch there are different development, so this is development track, actually this pretty much makes sense. So we have the development track here, so this is what this development developers are working on. Then there may be some different branches for different developers. So, and of course from one branch we can derive the changes here. Then at one point if we come from multiple branches, then we can simply merge the changes into one branch. So let's say in this case we have this branch which comes from here, and from here it comes, the changes are done here, then changes are done here, then we merge this with the main branch, we go next, until the end. So all the changes are merged at some point, and then at the end all the changes are merged in the final master branch, which is the main branch for us. Yeah, so we call it integration. Here it may be called different, but yeah, so this is the usual process. It may look a little bit complicated. This course will not implement all these structures, maybe just a couple of branches. And also the pull requests. So we have the central repository, we'll pull new changes to the local copy, and so now we have the local copy. Then of course we can have some word copies, some that will have one word copy. After that we push new changes, then we go to Yeah, so yeah, of course, this is fork, which checks the write access, because sometimes you may not have the right access to the repository. So this may be restricted, but if there is the right access, then it's fine, and we can forward the changes further. Well. Okay, so now we also have a little bit of agile. Yeah, this is just, to be honest, it's not quite related to Git, but okay, we quickly can go through it. So that's the topic related to the project management, also how you manage your changes to be delivered. And actually, this is say some kind of agile project as well, I guess. So you have one main branch, then you have some releases, yeah, and at the end, so time by time you deploy the changes here. So this is also some kind of agile, but yeah, so there is the so-called agile manifesto. The key sentences which how we can describe agile. So first of all, that's individual-centered actions rather than processes and tools. So it means that we mostly concentrate on the developers themselves. Then, of course, there is the development of working software and how the changes are done. Then the collaboration with customer, of course, and quickly responding to change. Yeah, so basically the idea here is that we develop the changes time by time. So there is development, and usually this is the cyclical process, some kind of cyclical process. So it means that development happens time by time. I guess this is the picture which describes this process very well. So we do changes. At some point we have several releases there, and then we deploy the changes time by time. Yeah, and the key part of agile process is Scrum. And this is what I said, that we do development, and time by time we have the releases. So first of all, how it happens. So we have the backlog. It means that these are all the tasks to be done in one particular project. And then we have the sprint. In this case, we do not mention about the sprints, but the idea is that we take some items from backlog, and then we have this, let's say, 30-day sprint. And once sprint is done, so during the sprint we work on these, the developers work on these items. Also, yeah, there's 24 hours. It means that this is daily Scrum. Yeah, we have every day. Yeah, usually it's every day. Sometimes, from my experience, it may happen till once a week as well, or usually we have it like twice a week. Sometimes every day as well. It depends on the project you're working on. And yeah, so the processes, we take the tasks, we go into the cycle, we go to the sprint, and that's fixed, let's say 1 month per sprint, and then we work on these changes. Sprint is finished, new functionality is deployed, then we move on with the product backlog. Here it is. We take new tasks up here, then we move them to the sprint backlog, and during the sprint again work on these tasks, and then we deploy the changes after the sprint is done. So what are the points here? First of all, usually, how it normally is described in Agile, that everyone just simply grabs the items from here and then work on them. Yeah, so in theory, no one should push the items to anyone, but in fact, on practice, this happens a little bit differently. But in theory, we should stick to this idea. And yeah, so at the end, so we work on these items, and we deploy the changes at the end. Yeah, so some key roles of the Agile process. So we have the product owner, and that's That's the main, you can say, guy, but in fact there can be multiple people who provide the input from executive team, stakeholders, customers, and users. And then based on this product owner, then the product owners, I guess we can say that there are lots of product owners, they create the backlog. Of course, we can run them by priority, rank them by priority. So, of course, the most crucial ones go first. Tasks, yeah. So these are the tasks, yeah. We can call them items. So the tasks, like if we want task, please make the logic do this, this, and this. And then another task would be that maybe revert the changes back from the previous release or something like that. Yeah, so there may be different tasks to be done. Yeah, so and yeah, of course we rank them by priority. Also, we can group them. Yeah, and then based on these priorities and groupings, we team selects the team plans the sprint. And once the sprint is started, so there is the selected items there, selected list of the items, and then the team works on the items during the sprint. And so there's Scrum Master who actually is responsible to control this process. Yeah, also there are some burn down of charts. So charts about the progress, how everything is going on there. At the meeting, as I said, and at the end there's sprint review and finished project at the end. But again, this there can be many sprints there, and only after the last sprint is finished and project is finished. But it's like a cycle, as I said, everything happens cyclical way here. And yeah, also after each sprint there's sprint retrospective where the team discusses what went wrong and maybe what can be improvements of the project and so on and so on. So that's just a short introduction in Agile process in general. And so now we will move to Git. I will explain what can we do here. GitHub, I will explain just examples after the break. Right now, if you have any questions, please let me know in Discord chat, and after the break I will answer them. There are if there are any questions about Git. But right now let's have the 10 minutes break. And we will meet at, say, 40 at 20. So let's have 10 minutes break. Okay, let's move on. So, and we will start with the I'll create the account on GitHub. Of course, obviously I already have it, but I'll create a new one. Just create this. So, it doesn't matter what kind of account, which Git remote server you use. You can use GitHub. I use Bitbucket. I mostly use Bitbucket, so you can select it as the option as well if you want. So that's up to you what you use. Maybe in this course, just to make it more interesting for me, we'll start with GitHub because that's the most, I guess that's the most popular remote Git server right now. So, and I guess that's the easiest one to use. So, let's register then. So let's sign up. And yes, I need to enter the email. So I will enter my Gmail account. This one. And let me create the password. So I will create the password. We will continue. And also let's create a username. I guess we cannot use dot here. So let's try underscore. Okay, underscore is not allowed as well. So maybe let me just simple my name, surname. Let's receive product updates. No. And let's first we need to solve this puzzle. I guess you can select anything. Should be fine. So registered. Then I need to confirm my account. That's right. So I guess I should receive the. Let's create an account. And password. Just I have now received the code sent to my email. Okay, the code is here. Copy paste it. And now we should. No. Oh no, that's not the right one. Sorry. Moment. Oh one. So, oh, hold on. Okay, this I guess is the new one. Yeah, this is the new one. And now we're here. So this is GitHub. In fact, so if you're interested, you can find lots of different projects stored on GitHub. So it's just simply you Google for something, you Google for some examples, some project examples, and then you most likely you can find the projects shared using GitHub. So basically, you can Google something, then you can navigate to the link, and you will see the GitHub repository with the code, which you can simply download after that. Okay, so now I have this GitHub, and first thing I want to do is that I want to create new project, new repository. So, and let's call it test rep. Name is available. So there's gitignore file, which is used to place not to place, to name the files which should be ignored by Git. So it means that you create, let's say, your repository, and this is your working copy. Then inside the working copy, you work on the files with the files, but the files will not be tracked by Git, so they would just simply be ignored by version control. And so this is what you can do using Git ignore. Will maybe not use it for this case, just simply have Git case. And in fact, you have all the main commands you may need to use. Echo is not used for Windows. That's why you can simply work with these commands. And here we have the link to our remote repository. We'll not use SSH, we'll just simply use HTTPS. So yeah, this is the link to this repository. And why don't I use GitHub Desktop? There's no difference. Of course, you can set up the GitHub Desktop. That's up to you. So just maybe to not have additional setup, you can simply move on with the web version. It doesn't matter at this point. You can use desktop version. It's fine, but for me at this point, for us, it's fine to proceed with web version. And there is not much difference. The concept is the same. So I guess there's nothing much to install, and so if you work on, and yeah, some usually now in the web development, it's not about Git, but about development in general. We mostly try to work with some web versions, with web solutions, because again we have limited, of course we have everyone limited memories on our computers, also to not have too much software on our computers. And also in addition, what I like, I guess most everyone likes in web versions, is that it's not platform dependent, so we can work with this solution on any platform. So it can be any operating system, also from your mobile devices. You can simply go here and then work, but again, it doesn't matter. You can also set up your desktop version and whatever. But okay, so let's move on. So we have this is the URL. This is the URL of our remote repository. Also, if you work with GitHub, so it will look like this. So you have first GitHub domain. Then we have this path to, which is our user, and after that we'll have the name of the repository. So you can simply access from if the that's one thing what we can do. We can go to settings, we can go to manage access, and so we can see that this is a public repository, so it's visible for everyone. So in fact, if I provide the link to you, so I can share it now. I guess I'm sure that everyone from you can open this link and will see this repository. Okay, so let's do some action. So first of all, we can see that we initialized this local. Okay, so what have you logged in? I guess you should also log in to all. One moment. I guess you should log in, but okay. So so one moment. Okay, you're logged in. Maybe try. So one moment. Okay, yeah, so yeah, okay. And that's fine. Yeah, actually I just tested it on my phone. My phone has no access to this hold on, let me double check. I tried also before the session with new user. This should normally work, at least for okay. Oh, okay. Then that's fine. Yeah, let me maybe double check from my phone. So, just to be 100% sure. Just repository. Ah, sorry, that's not right. Yeah, of course, settings. Yeah, I just, sorry, of course, this one. Yeah, sorry. Yeah, that's, I accidentally pasted the right, incorrect one. Yeah, of course. Yeah, thanks, Eva. Thanks, Eva. That's, now I edited the link and this should be correct now. So this one. Of course, you don't have the access to the settings page, but yeah, everyone should have the access to the repository. Yeah, and also, yeah, as I just said, you can easily find the access to the remote repository, so to many different remote repositories, by just simply accessing the link. Okay, so now we have this link, and now I also have this local Git repository here. So what can I do? So first of all, I have git bash. Again, for those who install Git, right click, git bash here. And so that's one option. For those who use other systems, then you can just simply go to command line, then so I type cmd, then I navigate to this folder. Copy paste this path, use change directory cd, paste path, and from here I can execute all the same commands. What I can execute from git bash. Yeah. There's no difference. If you want, you can use command prompt. Same again, you can use the terminal from your IDE, if it's Visual Studio Code or anything else. Okay, but I'll use git bash. It's maybe more easy way to do it. Okay, and first one is git. I'll add the remote path, so it means that I will link this local git repository to my remote repository. So then this git remote at origin, and then I paste the path to this repository. Yeah, so in git bash, Ctrl V will not work. So instead, you should use right click and paste. Okay, so at this point, now this repository will be linked to the close. Oh, no, okay. Not use it maybe a little bit later. But yeah, so now your local Git repository is linked to this remote Git repository. Yeah, so this is, as I said, this is considered as remote repository. Yeah, if we take a look on our schema, so this is this one. If we look at this schema, where is it? Oh, there's some file on top. This one. Yeah, so this is the remote server. Yeah. Okay, so let's do the first thing. So let's create the file. So that would be test file. Then I can make some quick changes here. So let's save this test file. Save it. So then what can I do at this point? If I use command git commit, git commit, then this is m, this means message. So let's say test commit, we'll see that there is initial commit, no changes here. And yeah, it also shows that there are untracked files, which is test file. So what we can do to track this file? The easiest way is add all. This means that add all the files, all the untracked files. So at this point we'll have this file tracked, and we can repeat our git commit command here. So git test commit, and now this file will be added to the test commit. So right now we added the file, it is committed, and now our changes are committed and they're located in the local Git repository with this space. And so we did this step, and the next step is that we push the changes to the remote repository. And to do this, we call the command git push origin master. So maybe let me explain this command. Git push, that makes sense. We push the changes. Then this one points to the what is the remote repository, because in fact we can have multiple remote repositories. Never did, but I guess we can have multiple repositories. So origin is the name of the remote repository. I added here, so that means if you want to add origin is the name of the repository, and master, this is the actual name of the branch. Master branch is created by default. This is the main branch used for the remote repository. I showed it here. This one. So that's the master branch. That's our main general branch of our changes. And I press enter, I execute the command. It says that permission is denied. Oh, hold on. Yeah, that's because I have different user. So a moment, let me then change the user. Yeah, because I have at this point I walked in with another user name. Okay, 1 moment. Yeah, I need to change the username. So 1 moment. Haven't done it for a long time. So let me quickly check it. Change and password. So 1 moment. Git remote. Just I guess I previously used another test user, and so 1 moment. So yeah, for you, so if you don't have the user registered here, this will ask you for the username and password. To add. 1 moment. Okay, I can use git config. Okay, 1 moment. So let me then enter my username. Some changes. Reset. Moment. Let me check this command. Okay, let's try again. Push origin master. Okay, it still uses the same. Moment. To reset, I need to reset username and password. Okay, quick moment. Okay, because this one can help. Okay, git config. That's to change the user. Let me say global. Let me say username. So it would be my name. We can identify it. Oh, one moment. Oh no, yeah, of course, that should be this one. So git config global. Then we set username. Where is my name? So that's the name, which is just simply to identify it. And then git config global. Then we set the email. And here I will use different email, which I just registered. Okay, and let's try again. Now I guess it will ask me for the password. Still, it uses the my previous. Okay, that's for. I still don't understand why it uses my previous. Okay, moment, git. Okay, maybe let's try again. Git config. Now I get remote. Yeah, for GitHub that's the strange setup. No, let's go back. Okay, one moment. Let's try this one. Git config potential username, and then I will add username here. Let's try again. I'm not sure why it still uses my previous password. Okay, one. Okay, let me try one thing. I will change the password. I will change the password for Koi. So, one moment. Okay. And this was quite specific for GitHub. So okay, in worst case I can use my test user I used before. Moment, I will quickly. Moment. That's interesting. Okay, maybe we'll do it differently again. And at this point, I will later on check it because I haven't changed the user for a long time. But what we will do, we will connect to another Git user I created before. So that's my another test user. Okay, I will use this one. I'll use this one and I will create a new repository. Okay, so test my first repository. We create this one. This will be public. So the same here. And so now maybe let's maybe create another Git folder. This first, and let's start again. So as usual, I start with initialization on the Git repository, and right now I can create the changes. Test file. So this is the first file. So it's here, and then again I add git remote at origin, and at this point I will add, in this case I'll add this one. Okay, so this one now is here, and then I can proceed with the same things. I add the user, I stake changes I done here, so that's my test file here, and then I can commit changes. My first commit, that's the text message we provide, and then of course we push changes to the master branch. Okay. Oh no, hold on. That's sorry. That's again my previous. Let's try again. Sorry. So we can sign in using different user. Yeah, again, I'm not sure why it's signed. Maybe I'll change the break quickly. Check it out, but right now I will sign in with my different user I used before, so that's my test user. I'll sign with this one, and I'll create again a new repository. Also, in fact, there's one more thing I can do. Yeah, so I just forgot about this quick thing. I can use my previous user and add the changing rights to another user. So that's also an option. So let me maybe sign in again with the user I just created. So that's this one. And what can I do? That's this repository. So I can add the access to this user. Okay, I need to, 1 moment. So I can find it here. This one. And I can add it. So I guess, okay, so now I'll have the invite. Yeah, that's also as an option if you work on the, if you collaborate, if you have the collaboration of your project, and then you have this invite. And so this is the invite you will have, and then you can accept the invite. And I need to, yeah, now I need to sign out. So normally again, if you work on multiple computers, then so from one computer you have one user, one computer you are logged in as one user, then on another computer you're logged in as another user. So this one, and now I can accept this invite, right? I should accept it here, accept annotation, and so right now I can finally work on this repository from different user. So let's try again in theory now. It should work. Because right now, yeah, so right now this user, sandbox user, has the writing access to the remote repository. Yeah, I will later on also double check how can I change the username and password. Actually, I did, but okay, it doesn't work. Okay, I'll later on check it once again. So right now I pushed the changes, so using this user, and so here we have it here, and now we can see that the text file is now here, and I can also check the content of this text file. So I can download this repository, I can download this as a zip file, I can clone it if needed, and then I can do whatever I want with this folder. But normally, how we proceed, of course, in this case, we just simply have this one file. Usually, we do the same with the code. And so maybe let's move to the let's go to my first project. We worked the last time. So let me open it. Ah, I already have it here. Maybe then let's then use this Hello World project as an option. Let's then open it in Visual Studio Code. So a moment. And now it should be here. So in IDEs used nowadays, so in more advanced IDEs than Visual Studio Code. So Visual Studio Code mostly we work using console, but in other IDEs you may find some more fancy tools where you can work with, on some stuff. For example, on the Visual Studio Code there is such option. If you go to source control, then it works a little bit strange way, but we don't have Git here yet. Yes, we don't have it. Yeah, we don't have Git here. What we can do, again, I have existing project. Again, I go to Git bash, and from here I can initialize this project. So I have this Git now, and I guess if we go to the I need to refresh it, I guess. Not now. It's too many. I'm not really sure why it was complaining about too many changes. Okay, it seems that it is loading. Okay, then in Visual Studio Code it does not really work correctly, so maybe in Visual Studio Code will okay. So I'm not sure why it shows me so many changes from other projects. Okay, yeah, in Visual Studio Code it does not really work correctly. Let's say maybe let me restart it. So I guess in Visual Studio Code this tool is not the best one to use. Maybe, yeah, as I said, I can maybe show you right now how it works for me in another IDE I use. It's PHP Storm. So that's used for PHP development, but for C#, it's Visual Studio. So maybe another IDE that's Eclipse or IntelliJ or anything else you will find. Let me maybe show you. Let's PHP Store. Okay, so now Now all the changes are here. So, and what you can see here, here we have untracked changes, and they are also covered in green. Yeah, it means that the changes are unstaged. So you can also see it here, and in fact you can uh, you can also manage Git from here if you want. Maybe we can do something from here, but the same way we do it from console. So in fact, there is no difference if you make the changes, if you do the actions from here, or you do the actions from terminal, from console, from Git bash. There is no difference, in fact. So maybe there are some complicities here, but there is no actual difference. Okay, so let's create the repository for Hello World. And maybe let's do it. Okay, I logged in as Sandbox user. Guess that should be fine. For now, let's create new repository and I'll name it Hello World. So it's public. Nothing to be added an addition here. Okay, so now again I have this remote repository. All I need is the link to it. And what I can do here, so I can run the command git remote at origin and then the link. But I can also do the same approach. So one approach is that I go here, I have remote, I add remote, and there's an option add remote from git. I guess I can add it from here. And yeah, so if you use the option git remote, add remote from GitHub, you can directly select the repository from here. Yeah, so many IDEs have the pretty nice integration with GitHub, so you can simply use this option if you want. It will make your life easier. Then I write the remote name, I'll name it origin, and so now this local Git repository should be linked. So at this point, all these changes are unstaged. It means that so maybe I can select separate file. So let's say this one. So I select only, we have lots of files here, but what I do, I select only Hello World. So and then I can press, I can press pause. Means that I will stage only this one change, and not all the files from here, but only this particular file. And maybe let's go to this one. We'll just randomly I'll select files. In fact, I can do all these steps from console, but as an option I can do all these steps manually. So I have, let's say, 2 files staged right here. So what can I do? I can commit this change. These files I can also commit all if needed, but I will just commit these 2 files. So, and let's say that, so I need to write a message. And I will say 2 files committed. Then, so now commit is loading. And so now everything is committed and I can simply push changes. Okay, so let's push to master branch. And so now it's loading. Yeah, maybe Visual Studio Code also does it a little bit slower than it goes from console, but right now I think that okay, I guess we should have something come out. No, okay, we don't have anything from output. Okay, and if we go to the remote repository now, we have these 2 files, so it's pretty much straightforward. Also, yeah, maybe for you to understand the difference between commit and push. So let's say that we will commit these two files, or 3 files. I don't want to do the file. So let's commit these 3 files. So we go to commit. So let's say commit A, and we can call it, yeah, of course, normally we should find the relevant word, relevant description for the commit. Yeah, usually you describe what are the changes done there. Simply commit, so provide the commit, and then I can, so right now everything is committed and I have a new changes to be staged. Yeah, so let's say add these 3 files. And now I have 4 files staged. And then again I go to commit. Yeah, so only these files will be committed. Let's say commit test. Let's commit B. And yeah, now we have 2 commits. Now let's go to push. Yes, now I'll push these changes. And so pushing is push now. And we go here, and so we see that we had 1 push, but actually with 2 commits inside. So there's 1 commit here and another commit here. The interesting thing here is the folders. So what happens? Actually, the folders themselves are not staged. Yeah. So you need to have the file, which tend to be committed and pushed. Yeah, if you just simply created the folder, you have no files there, then nothing is pushed. Folders themselves are not pushed. Yeah, the path to the files are pushed, but not the folders themselves. Yeah. So if you have the file stage, then also the folder will appear here, and this is what we have now. Again, I will share the repository with you, just in case you want to have a look. And so you will see it then. What I said, you can proceed using this tool. In Visual Studio Code is pretty simple, but for example, let me select another ID currently open. That's a local project. That's for PHP store. Hold on. See this, how it looks like, and here we have this Git staging tool. Here it is. And so this provides maybe more precise information about the branches used, about the history of commits. You can also see the version changes. Okay, so in modern IDEs, it's yeah, we can compare with local. You see, it also shows the files. It's possible to track all the changes using modern IDEs. We'll maybe look do it a little bit later. For now, let's maybe do some steps related to the branching. So for branching, again, I will just to start for you. I will make I'll maybe switch back to our test project, because it's more simple for us right now. So let me maybe go back to this hello world. No, hello world. This one. So it's this test file. And so okay, let's go to Git Bash. So you can briefly change close your Git Bash. You will lose nothing. So nothing will be lost. All the usernames, all the settings will be saved after that. will be saved and everything will be in place. So let's first we create a new branch. And to create a new branch, you need to use command hit branch, and this will be say so I'm gonna provide the name. I'll name it, let's say, for well, let's say branch A. Branch A. So I created new branch, and so at this point nothing will happen. Yeah, because I will still be working on the main branch, which is master branch. And this is what you can see here. Yeah, I only created this branch. To switch to this branch, I will then use the command hit checkout, and I will check out to this branch. And so now I switch to branch A, and here it is. Yeah, so now I'm working on branch A. What does it mean? Let's then create any changes here. So let's say that this would be test file A. And so that's first file. So then I will stage it here. And basically I stage all the files this way. And then I commit changes. So this would be file added branch 2, branch A. And then I commit the changes the same way. Not commit, but push. Changes first to push origin master. And so, what will happen now? We refresh here, and hold on. Yeah, sorry. Yeah. Of course we need. Yeah. So what happens at this point? That's a real interesting thing. Right now we create a new branch in our local repository, but it's not visible in the remote repository. So here we still have only this one master branch. And so how to deploy the branch, our new branch, to the remote repository? So as you can see, we usually call the command git push origin master. That means that we push to the origin repository, remote repository, and we push it to the master branch, which is this branch, on branch 1. But right now we're working on branch A, so that's a different one. And in this case, so what I need to do, it's quite simple. I need to change different branch. That will be git push origin branch A. Yeah, so right now the changes from this branch will be pushed. I mean, this one file will be pushed from the remote repository, and what we will see. Now we see that still one file is here. But now I have two branches. And so I can switch in between the branches. And now I can see if I'm on the branch A. Yeah, so I have this branch A, and it has two files. If I go to master branch, it still has only one file. Yes, so it means that right now I'm from here, all the changes I do, I change them under branch A. So then we can do it differently. And so now we can check out back to the master branch. So let's git checkout master. Now we are back to the master branch, and let's create. Yeah, and yeah, interesting thing here is that you can also see that you don't have this file anymore on your in your folder. Yeah, so that's a little bit of magic. If you switch between the branches, so it's not here. So if you're on the master branch, it's not here. If you switch back to the checkout, if you switch back to the branch A, then the file should, oh, hold on, sorry, title, git check out branch A. So now we're back to the branch A, and the file is here. Again, back to the master branch. Still, our file is not here. So we are back to this branch. Yeah, local is still replicated. Local is not replicated. And basically, this is why the local Git repository is needed. So at this point, you can see that I do not touch the remote repository. Yeah, so I only work at this point with the local Git repository, so with this folder. And yeah, maybe a small remark about this folder. If you have large project, then just I can show you one example. So let me quickly show you, check if I have this one example. One moment. Okay, maybe I don't really have, but yes, I can simply explain you. If you have large projects with lots of change history, then usually you should understand that this Git folder may be quite heavy, so it may take maybe some gigabytes of your memory. Yeah, if you have large projects, so be careful. Yeah, it's not careful, but please know that that size may be quite significant here for Git repository. So that's one point. Okay, so and let's say that I will create a new file. So that would be test file 2, maybe something like that. So I can type some content. Again, at this point I'm just creating text files because it's the easiest way to create them. Of course, you may in real life, of course, we usually create the programs. We'll later do the same with the programs, with the classes, yeah, with the coding files. At this point, just the most simple way would be if we just simply create text files. Yeah. So it would be test2. And okay, so again, I'm on master branch. So maybe let's copy it. I will delete it. I'll do a different way, just to make it more interesting. I will create new branch. Git branch B, branch B. So now I create a new branch and I will check out. Yeah. Git branch means I create new branch, and git checkout means that I switch to this branch. Branch B. So now I'm here, and let's maybe paste. Cannot paste it for some reason. Okay, let's go once again. We test file 2. Some content here. Again, it can be any file. And so now let's add this branch. Then let's collect from this branch B. Yeah, and now I can push the changes, git push origin, and this time I will have branch B, right? Okay, so now everything's pushed, and now we will see that we will have 3 branches here. Okay. So under branch A we have file A, and here we have a new file. So, and this is how it usually happens. So we have this. Okay, we don't have pull requests. Yeah, in Bitbucket, let me quickly show you how we focus in Bitbucket. In GitHub, yeah, I usually recently only worked with GitHub. And maybe let me show you how it looks here. I guess somewhere in GitHub you can also find this option. Maybe let me quickly search for okay. Okay, maybe let me select one of the folders I have here. Select this one, and yeah, so we have these branches here. And okay, I just used only one branch, but let me maybe check a little bit. A different one. Okay, let me check this one. I guess yeah, this may be on. Oh no, I still have only one branch. But okay, that's never mind. You may have the more visualized version of the branches. Yeah, so you will have one main branch, and I guess there should be somewhere here, but yeah, okay, it doesn't matter. So yeah, in this case we know that the master branch is the main branch, and we have these two derivatives from the master branch. Yeah, so and how it usually happens, usually we need to merge these branches into one branch. So, and in this case we use merge operation. Yeah, and so what we usually do, we usually go to the master branch and we merge changes from different branches. So first of all, let's select branch A. Now we have the file from branch A, and then we merge branch B as well. Okay, this says that okay, yeah, first, yeah, that's correct. First we need to comment the changes from here, as it asks me. Okay, this would be merged A. Yeah. So, and right now, since I merged that one, I can merge branch B, but I guess it's already merged here. And so let me just double check. Yeah, I guess nothing to merge right now. It's already merged. As you can see, the file is here and already up to date. And the last thing to do is now simply push to master origin, and so now here we have everything. We should have everything up to date. Sorry, not here, but here. So we'll have 3 branches, but under master branch we can see that everything is in place. And in addition, what we can also see next to each file, we can see the commit from where it comes. And as you can see here, initially the file was changed and created in our case, is created under branch 2, the same for this file. It was added from branch A, so it will have the corresponding commit from where it is added. And the merging commit is not used here, so but it is placed here. Yeah. So yeah, all the files are up to date right now, and okay, maybe let's have the 10 minutes break now. If you have any questions, please let me know, and we can write them during the break. Let's Let's have a quick Okay, so I hope that now you are pretty much able to work with some basic Git commands. So yeah, and so in this practical assignment, there's almost everything what I just shown. Yeah, there are some simple commands: git merge, git push, git checkout, git add. One thing there is git add dot used, so that's up to you. So you can use dot, you can use as I used git add a. That's up to you. I guess for me, at some point git add did not work, so since then I started using git add a, but there should be no difference there. Okay, and yeah, all the other steps should be pretty much the same as I just shown. One thing is about working with groups, so that was the point number 7, and so right here I want you to collaborate. So please, yeah, I wanted to say please split into 4 groups of 5, but I guess you do not really know each other. Maybe if you know each other, then you can so let me quickly think. Maybe if you can find a way how you can split in groups of 5 till tomorrow, then please let me know. If not, then I will just randomly split you using the program code. So that's so for you. If you have the options, you can decide. But so that's not like pretty serious working group. Yeah, so that's just simply that you all need to work on the same remote repository. So just one of you will create the remote repository, and then you all need just to make the changes and push there. Yeah, so that's up to you. If you find a way until tomorrow, then please let me know. If you have some kind of ideas how you can split yourself into 4 groups of 5, then let me know. Again, otherwise I will just simply randomly split you. Again, there is nothing there should nothing special be in these groups. Just again, only one of you should create the remote repository, then add the others as collaborators, and then just you should work on the same remote repository. Okay, the question from Wanda, assignment number 3, create new directory. Okay, this one. This one. The new directory was new read name file in your local system. Okay, just it should be added to GitHub. Yes, you can. You will need to add it to GitHub. One thing I guess there is no mention about gitignore. It's never used, I guess, right? Yeah, gitignore is not used. Maybe I can also just for your just for you to know. Let me maybe also I'll show you how gitignore file works. So maybe I can add it to this directly to this project. And yeah, one more interesting thing here is that you actually can create under the master branch, but normally you should also basically any change you do, either from here or from somewhere else, you should follow the process as we just did from the local branches, from our local machines. So it means that you should add the changes under the branches. You should have the commits. You should stage your change. You should commit your change and all this stuff. So you cannot just do it differently. Yeah. So everything should be added using the commit. So one moment. Let me add git ignore file then here. So that's just my moment. This one. Okay, so let me maybe add git ignore file. So one moment, just to clarify the format of this file. So it should be, it's funny, but that should be created as, simply create new as text document, and we should remove the extension, so we should not have any extension, and it will be named git ignore. Yeah, I'll change the extension, and this will simply be this such kind of file without any extension. So this is git ignore file, and how this will work. So one moment, I'll just double check the format. So that's, I guess, no, sorry, not git ignore, but dot git ignore, of course. Okay, so dot git ignore, it should be, it's actually the text document. Oh, that's one example. Yeah, that's just a simple example. You should need to provide the paths, the folders. So for example, let me create two folders. One will be folder A, the another will be, let's say, folder B. Folder B. And what I can do, I can say, so I can open the file, git ignore file, and I can mention folder A here. So what does it mean? It means that, let's just do it this way. I will create one random file here. It's a random file A, and under this folder we will create random file B. File B, and then I go git bash here. I git add, then I commit changes. So this would be git commit, say test git ignore. Okay, then this should be git push origin master as usually. Okay, so let's see what happens now. Okay, git ignores here, that's fine, but you can see that folder A is not added. Yeah, so basically it means that simply all the folders mentioned here are not tracked using the git. And so git ignores this folder. And the question from why it's always git add, I simply use git add to add all the files. Yeah, so it means git add stage all the files. Yeah, so all the files I changed, then they will be tracked. Yeah. So it means that I change, let's say, this file. So here is the change. Then I change this file. Then using git add, I will add both these files. They will be added to the commit. Yeah, so I can select these files one by one if I want, In fact, if we use git add dot, it should be the same. Yeah, it should be the same as git add. So now nothing weird, but it should be the same. So then we commit. Files changed, and then I will push. Change it. Wait. Push origin master. What's going on here? I can typo. So git. Let's make this over. Git push origin master. So git add a or git add dot means that we stage all the files. Yeah, there is the option I shown you here that we just simply stage the files one by one. So that's also possible. Git add means that I simply stage all these files. Yeah, in console it's also possible to stage them one by one. I don't do it from console. I usually use IDs like here. Okay, so just add them one by one. But in console, let's maybe do it. I don't remember the command. Let's maybe double check. Add select files. So let's change this file. Yeah, so the file tracks changes. If you add a new file or if you do the change in the file, then they can be staged and then can be and so you can see that files changed. This comment is applied to these two files. Yeah, I guess so. Right here you can also see the history of the files. Okay, never mind right now. So yeah, you can see that we changed these files and we staged these two files. Also, it's possible to add particular file. Yes, you should. You should only provide the path to the file. Okay, so let's change the same files. It doesn't really matter. What do we change? Change to. Let's maybe do the same here. Change to. Yes, so then I can stage, let's say, only one file. This would be. We change this one, right? Yeah. So then let's provide the path to this file. So then I paste it here, and I guess it should work, right? Yeah. So now I staged this file only. So despite the fact that I changed two files, so now if I do the commit, only one file staged. So right now only one file will be pushed. Yeah. So that's why we use git add a. Yeah, it means that we add all the files, and from my experience this is what we usually do. Of course, if you want to add files one by one or select a group of files, then you can use git add and provide the path to the file. But just to simply add everything, and we use the command git add all. Yeah, add a. So yeah, that's the home task. If you have any more questions, then please let me know. Yeah, so about your repositories, how you need to submit, and this is the answer to how you need to submit your home tasks. So for this one, so this is for Git, the idea is quite simple. You just need to share the Git repository with me. So just simply provide me the path to your Git repository. I'll see all the changes. For all the upcoming practical exercises, so it will be the same. I guess, let me think, I guess you will not create new projects for every, or I guess you will. Okay, let's see, but what you can do, the idea would be quite simple for your home tasks, for your practical assignments. I suggest you to create one folder. So that would look something like this. Yeah, all practical assignments. Yeah, then initialize Git repository here. So that would be here. Yeah, initialize Git repository here. Then connect this repository to your remote repository in GitHub, or again you can use also something else. Yeah, Bitbucket as an option would be, and then just simply share this repository with me. If you use GitHub, then as I just said, you can simply provide the link. Yeah, the link to your repository. You don't need to provide me writing access, because I won't write anything in your repository. Yeah, so inside this folder you can simply create new assignments. What would be, let's say, assignment 1. Yeah, this will be assignment 1. Then you may use this as a project folder, and do any changes from here, and then for assignment 2 as well, doing changes there, and so on and so on. Yeah, so all you need to share with me is this folder. Yeah, this folder for all your practical assignments, and then just simply share it with me, and I will see everything done by you. Also the comments you do there, so I can also track the changes, what's done here, so when you finish them, and so on and so on. Yeah, so I hope that's quite it makes sense. Yeah, I will also add it to the welcome and rules section. Yeah, so maybe for those who missed it right now, I will then add it right here. Yeah, under the rules section, and then so everyone can check it out. Just share it with me in Discord, or just select any other option via email. But yeah, I prefer if you contact me in Discord. Yeah, that's the first contact channel for me. Alright, so yeah, okay, I see that Christine is typing something. Okay, yeah, if you have any questions, something is unclear for you, then please let me know. Okay, yeah, that's for sure. So, okay, Christine is typing. Okay, let's see where we can find the session recording. Yeah, that's yeah, so all the main information, yeah, that's the last question. All the main information I shared under welcome and rules. So I guess you can simply find everything in this YouTube channel. 1 moment. Just double check. So I guess you can. Yeah, all the sessions are streamed live on YouTube. Okay, yeah. Yeah, so you can go to the videos, and here you should have, yeah, currently we have this live recording, and you can also just check the recordings of these sessions here. Yeah, so here just under the videos, as I said, I will name the recordings as the Macintosh.NET 6.1, that's our group, and the date of the session. Yeah, so you can easily find the date. That's one thing. And okay, let me pause it. And another thing is that you can check the agendas. Sometimes the agendas. Moment. Guess we have the agendas not here. Sorry. Session planning, yeah, here. So here we have the agendas, and then you can simply open the agenda and then navigate to the session, and so then you can find what are the topics of the session. Okay, so that's, and yeah, I will also try to put relevant information. Maybe if something, yeah, I will also describe the information about the practical assignments here. Yeah, so maybe, yeah, the information how you should submit them. So this is basically what I just said. I will just simply write it here. Okay. So more questions are welcomed. So there is the question from Sabina. Okay. To sum up until tomorrow, we have to. No. You don't. You don't need to complete the practical assignment until tomorrow. Yeah. No. Until this is until the end of the week. Yeah. So I will until the practical under the practical assignments channel, I will provide the deadlines for the practical assignments. Yeah, so for this practical assignment, deadline will be next Monday. So you have 1 week. Of course, I understand that right now we have 4 sessions in a row, so actually you're not supposed to have time for the practical assignment. That's obviously, yeah. So that's why, of course, you have time until next Monday. So, wait, let me then write it here. So practical. So yeah, I'll just simply I'll do it this way as I will apply it. So this would be line. This is next Monday. Yes, so that would be next Monday. So not until tomorrow. You just if you have the ideas how you can find the way to split in groups, then please let me know. If you won't find, don't worry, that's fine. I'll just simply then tomorrow I'll split you randomly in groups, yeah, in the 4 groups. And there's nothing that's inside the groups that you should. One group can be weaker than another group. It's not about this because there is nothing what you really need to do in groups. The idea is that only one of your group will create the remote repository, and then everyone else will just simply make the changes there. Yeah, so that's about groups, but of course, no deadline until tomorrow. Yeah. So deadline is next Monday for the practical assignment. So that's about it. Okay. Any more questions? Yeah, if you have any questions about Kit, then you can briefly ask them now or also after the session, so or before next session tomorrow. So I have time. I will reply to your questions directly, and also we can discuss it during the session tomorrow as well. Yeah, so I guess right now we are, from the theory perspective, we come through Git. Actually, one session that was quite fast, but these are the basics. Don't worry, we will not work with. Yeah, we did not talk about pull operation, and there's also fetch operation, which is maybe a little bit. Yeah, in theory, git pull is maybe a little bit more complicated, but if you have the version synchronized, then nothing special should be here. You can also try git pull. Yeah. I guess in your practical assignment there's. Oh yeah, okay. You also have git pull. That's fine. You can try it. And yeah, so with git pull, sometimes you may have some tricky points. Yeah, so please let me know if you face them. I will then explain about git pull. But the idea is quite similar to git push, but on the opposite direction. But yeah, please try and then let me know if something goes wrong for you. Okay, so then if there are no more questions, then I guess for today we can finish. And yeah, one more thing about Git. Later on, when I will create the code examples, I will most likely also use only one folder, only one Git repository. Then I will also share this repository with you, so you can have the code from the sessions available for you. Git remote Git repository. Okay, but I will share it a little bit later once I start coding. So now just prepare for the coding. Okay, so then